The first thing we want to do in this example is to determine the minimum number of unknowns to analyze this circuit using nodal analysis. This step is really important. It can tell us how much work nodal analysis is going to be for this circuit. Later on, we'll have a variety of analysis approaches we can use, and our first question should always be which is the least amount of work. To determine the minimum number of unknowns using nodal analysis, I have two approaches that I typically use. They actually boil down to the same thing, but they look superficially different. For the first approach, I identify supernodes. Supernodes contain the voltage sources. So I'm going to put the voltage sources inside of supernodes. If I do that for this case, I have a supernode that goes all the way around here. My other nodes are here and here. Now, once I've defined all the supernodes and regular nodes, I count the number of nodes and subtract 1. I have 3 nodes now in this circuit. This node down here in the lower left, the supernode, and this node in the upper right. So I have 3 nodes. If I subtract 1 from that, I get 2 unknowns. An alternate way to do this, if you're uncomfortable identifying supernodes, is to kill the sources and count the remaining nodes after that step. Killing a voltage source converts it to a short circuit. Resistors aren't affected. Killing a current source results in an open circuit, so this 6 amp source becomes an open circuit. This 10 volt source becomes a short circuit. The 12 ohm resistor doesn't change, and these 2 resistors are not affected by this step. Now I have 1 node here, which basically just corresponds to my previous supernode, except that I don't have to worry about a voltage source if that bothers me. I have another node up here, and I have another node down here. So I have 3 nodes. I subtract 1 from that to get the total number of unknowns. So 3 minus 1 is still 2 unknowns for this circuit. Next, I want to assign variables in a couple of different ways for this circuit, but I always want to come back and make sure that I only end up with 2 variables, otherwise I've probably done something wrong. To define valid nodes, the first thing I do is choose a reference node. The reference node is always completely arbitrary. For this first time through, I think I'll choose this as my reference node. That becomes my reference voltage, which is 0 volts. Second, I'm going to choose my dependent nodes. Voltage sources separate dependent nodes. So for example, this 10 volt source, the node on this side of the source and the node on this side of the source will be dependent. If I know one of those voltages, I automatically know the other, since I know that there's a 10 volt difference between those 2 nodes. So I'm going to arbitrarily choose one side of that voltage source as being independent. That will by default make the other side dependent. I'll choose this one as my independent voltage V sub A. This voltage is 10 volts lower than that voltage because this is the positive terminal, this is the negative terminal, so this voltage by default becomes VA minus 10 volts. Any remaining nodes will also be independent. The only node left is this one. That'll be an independent node. I'll give that a variable name V sub B. So I have 2 independent voltages. Those are called VA and VB, and that is consistent with my previous assessment. Let's do this problem one more time with a different set of defined nodes. I'm still going to choose a reference node. Again, that's arbitrary. I think I'm going to choose this node here now to be my reference, and that's going to be 0 volts. Finding dependent nodes. Those are separated by voltage sources. So this voltage source here means that this node and this node are dependent. Since I've already assigned the voltage over here as being my reference node, this is going to be a dependent voltage. The voltage source polarity says that this node is 10 volts higher than this node. The positive terminal has the higher voltage difference. Since this is 0, this is 10 volts minus 0 volts, which is just 10 volts. Finally, all the remaining nodes are independent. This node is going to be independent. I'll call that VA, and this is my only other node. It'll be independent. I'll call that VB. Again, I end up with two independent nodes. I've chosen to call them VA and VB, but they're not necessarily the same variables as they were on the previous section of this example.